first thing we want to do today is learn to calculate the mean ionic molality, which is actually M plus minus, and the ionic strength, which is labeled as I. Let's say, assuming today you throw a salt into the aqueous solution, we can always start from the simplest case, sodium chloride. In the aqueous solution, we know it's going to dissociate and become sodium plus Cl minus Aq. Assuming the concentration of your sodium chloride is actually M. So we want to calculate our M plus minus. M plus minus is actually equals to concentration of your cation raised to the cation's power times the concentration of your anion raised to the anion's power. But you need to actually take the mu's root so I can actually get the mean ionic molality. To calculate your ionic strength, the equation you use is 1/2 times summation Mi times Zi raised to the second power. This is another equation that you need to memorize so I can know how to actually calculate your mean ionic molality and the ionic strength of your solution. With that being said, let's look at our first example. Sodium chloride. That give you sodium plus and Cl minus, with the initial concentration of your sodium chloride was N. So let's say look at the condition number 1. Your mu plus is 1, right? Your mu minus is also 1. Your mu, which is actually the sum of mu plus and mu minus, therefore is going to equals to 2. So your M plus minus will equals to what? We know your M, once it dissociates, is 100%, right? So your sodium plus will have concentration of M. Your chloride minus is also have concentration of M. Therefore, your M plus minus will be M for your cation raised to the mu plus power, which is 1, right? Times your M minus, which is also M raised to the first power. Take the mu's root, right? In this case, your mu is actually to 2. Therefore, it's going to equals to just M. So your M plus minus is going to equals to M. So let's look at your Z plus Z minus. Your Z plus is equals to 1, right? Because it's sodium plus. And then your Z minus is Cl minus, right? So it's also equals to 1. Then to calculate your ionic strength, what you do is 1/2 times your M plus times your Z plus square plus your M minus times your Z minus square. So your M plus is just M, right? Z plus is 1 raised to the second power plus your M minus is also M times Z minus is also 1 to the second power. So this is actually 1/2 times 2M. So your ionic strength is also just M. Today, if I give you another equation, which is MgCl2. Again, it's a strong electrolyte with initial concentration M. It's going to produce Ng2 plus 2Cl minus. Once you reach equilibrium, you will know that the concentration of your M plus, okay, is just M. But for your chloride minus, you will become 2M. So for condition number 2, your mu plus is 1. Your mu minus is 2. Your mu total will be 3. Because mu is actually mu plus plus mu minus. For the charge, Z plus will be 2. Z minus will be 1. Once we write all these down, then we can actually calculate our M plus minus. Your M plus will be just M raised to the mu plus power, which is M to the first power. And the second one will be 2M raised to the mu's power. Okay, and the whole thing need to take the mu's root. So in this case, your mu is actually 3. So it's actually M to the first power times 4M squared. Trying to take the cubic root of that whole value. So once you do this, you get the cubic root of 4 times your M. And then for your ionic strength, it will be 1/2 times your M plus, which is M, right? Times your Z plus, Z is actually 2, right? So it's actually times 2 squared plus your M minus 2M times your Z squared, which is your 1 squared. So this will be 1/2 times 4M plus 2M. So this is actually 6M, right? Eventually, all you have is 3M for your ionic strength. Example number 3. Assuming today you are going to have magnesium sulfate with initial concentration M, and it becomes Ng2 plus SO4, 2 minus. What is your mu plus, mu minus? Mu plus is 1, mu minus is 1. Total mu is 2. Z plus is 2. Z minus is 2. Again, when you calculate your M plus minus, it will be equals to concentration of your M plus is actually M to the first power times M to the first power. Then do this. So your M plus minus is still equals to just M. Calculate your I will equals to 1/2 times M times your Z plus is 2 to the second power plus your M minus, which is M times Z minus is all 2 to the second power. So your N is going to be 1/2 times AM, that's 4M. So you know in this case, your ionic strength is actually 4M. If today you have example number 4, so if I give you a solute like this, say this is actually a strong electrolyte with certain concentration, you will need to solve all this table. Okay, if I ask you what is the mean ionic molality and the ionic strength of the solution, then you should be able to calculate yourself. Another thing that you should know is the ionic strength is additive. What I mean by that is actually, if today I say I have a solution containing 0.1 M of sodium sulfate and 0.2 M magnesium chloride, when you calculate the ionic strength of the overall solution, so ionic strength of your solution will simply equals to the simple sum of the ionic strength you estimate of your sodium sulfate solution plus the ionic strength of magnesium chloride. So if that is the question you got asked, okay, then first you need to calculate the ionic strength from each individual species. And then you add it up, then you will know the final ionic strength of the solution. In order to know the activity, you already know how to calculate your mean ionic molality. The remaining thing is actually your gamma plus minus. Okay, once you know both of this, then you can actually write out your activity. Okay, then you can actually apply to all the things you learned in the previous lectures.